Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is AIDA NABIHAH binti Abu Bakar, and today I'll be explaining to you about my individual projects with the title Automatic Bus Waiting Area System. So today I am going to present a project on the bus waiting area management system using Arduino Uno. So this project is designed to manage the flow of people entering and exiting a bus waiting area to ensure safety and preventing overcrowding. So I'm going to list out all the components that I have used. So I'm using Arduino Uno as the microcontroller and two ultrasonic sensors for distance measurement and two servo motors for gate control, one LCD display for occupancy status which I use I2C, and breadboard for connecting all the wires. So before we dive deeper into my simulation, I'm going to show you my 3D design for my bus waiting area. So this is my bus waiting area. I created this 3D model by myself by scratch. So I couldn't find any bus model. I'm just using car to do the simulation. So just imagine this car is a bus. Let me explain on how the system works. This is the entrance gate and this is the exit gate. If you can see down here, there's like a blue box where I put ultrasonic motion sensor both at the entrance and exit gate to detect people. This is the servo motors which are connected to the gates for automated opening and closing. The blue and black thing is actually LCD which is connected via I2C protocol to display the number of people inside. So this is my 3D model. I'm going to show you my top view. This is the top view. This is the front view. And this is the side view. So I put all the components here. This is the Arduino Uno. And this is the ultrasonic, this is servo, and this is I2C. So let's move on to the simulation. So let's take a look at the coding first. I have included all the libraries, which is servo H to provide function to control servo motors, and wire H, which can enable communication with I2C device, example like LCD. And this is liquid crystal library to provide function to control the LCD display over the I2C interface. So from line number 7 till 17, this is where I define all the pins and threshold. So for ultrasonic sensor, I have set it 2 for 2, 3, 4, and 5. And there's like two sensors are used, one at the entrance and one at the exit. So for servo motors are connected to control the entrance and exit gate. So my threshold, I have set it to 100 centimeters to detect a person. And the max people allowed in the area at one time is 20 people. And this is my global variables. As I mentioned before, the servo and the LCD object, and also the person counter are used in this program. So this is my setup function. Okay, here, this serial communication which can enable motoring via the serial motor. And for the trigger sensor pin modes are set as output to send ultrasonic pulses. Echo pins are set as input to receive reflected pulses. Servo motors are attached to the pins and gates are initially closed. That's why I write it as 0 inside the brackets. This is my function for distance measurement. It sends a 10 microseconds pulse to the trigger pin and use pulse in to measure the time it takes for the pulse to return and converts the time into distance in centimeters using the speed of sound 0.034 divided by 2. This is the formula to convert the time into a distance. This is the void update for LCD and it clears the LCD seconds line and updates it with the current person counter. Either it will increase by 1 or decrease by 1. It depends. And here, as you can see, this is my main loop logic. This for my entrance logic. It checks if a person is detected. So I make distance 1 less or equal to distance threshold. And if the maximum capacity has not been reached, it opens the entrance gate. All right. And it waits for 2 seconds to allow the person to enter, which I put here 2000 milliseconds. And it closed the gate back to 0 degree. So the increments and the counter updates in the LCD. And here, it will show how many people in the area from the LCD. And if it's full, else, I use the function else. So if the area is full, area full, no entry allowed is showed. So same goes to logic gate. For the exit gate, it checks if a person is detected at the exit. And if there's like a people inside, it opens the exit gate and wait for 2 seconds to allow the person to exit. And also it closes the gate and decrement the counter and also update the LCD in real time. And if you can see here, I put a small delay for 200 milliseconds to avoid the continuous triggering of sensors. I'm going to put this ultrasonic sensor for the entrance gate between 0 to 100 centimeters. Let's start. Maybe I'm going to put around 72. All right, so the entrance gate. People in area 1, 2, and then 3. So you're going to increase. So right now, currently there's 90 people in the area. And if it's full, this is going to show area full, no entry allowed. The exit gate. I'm going to set it around maybe 60 or 40 centimeter. And the person in the area is going to decrease. So from 17 to 16 to 15 and to 14, so on and so forth. So for now, the exit gate is around 2 people in the area. It's going to be 1, it's going to be 0, and then there you go. No people in the area to exit. So I think that's all from me. I hope you enjoy my explanation and you understand on how my program works. Thank you so much for listening to the end. Bye bye.